Thank you so much. Hello, embracers. Hello, watchers. I think this is the majority of the group here. What makes AI really successful? AI, traditional and Gen AI. I think it is about safety, about trustworthiness, and also ethical decision-making that needs to be baked in to all the decision-making of business applications. And this is exactly what AI governance means. It's a methodology, it can be implemented as a framework, but also the tooling about it. And I'm wondering, who of you has ever experienced or get their hands on working with AI governance tools? So we have a few, very good, but not the majority. I think it's still key. And today, dare to know. I will show you what we are embedding in our platform for data science, traditional AI, machine learning, but also Gen AI, obviously. And it's for different roles, data scientists, data engineers, preparing data sets, governing data sets, developing models, but also for the operational perspective. Once we set these models live and use them in our applications, monitoring them. Make sure that we derive the right decisions and it won't behave badly in the future, as we have seen in a couple of examples. And this is all in the context of AI, watsonx as a platform. And the newest edition released last month is watsonx AI for governance. One of the components that is deeply baked into the whole process, into the whole life cycle of data science and AI engineering. I will give you today an example. It's a small application that we developed. Put yourself into the shoes of a claims agent of an insurance company. So you're working day in and day out on car accident reports that have been filed, a lot of natural language text, basically. Let's switch to some example application here. Customers can submit their reports either via call centers, we generate lengthy transcripts, or it could be via conversational AI to get the information that the agent needs. The agent then goes to his laptop, sees the bunch of claims that are waiting for his response, and he needs to decide which of them are acceptable. Do we have enough information already retrieved from the clients? And also identify very early in the stage if there are any fraudulent submissions to it that will just cost money to the company. So here we have a small picture, we have a description provided by the end customer, what happened during the car accident. The first step where we use generative AI in this application for the agent is, let's help them to get quickly to the points, to the facts. We generate here, on the right-hand side, you will see the summary of the text coming up, which is extremely helpful to get a first view on what actually happens without reading pages and pages of documentations. But we also generate for him, what are the next steps? Do we need further information, clarification from the policyholder? What else do we need to enter into the back-end systems to process this application? And also extract key information. Where did it happen, when, with which car? And then it's very easier and simpler to quickly decide how to proceed with this claim. This is the application we have here in our use case. And how we implemented this, basically, for the 3 generative AI tasks, we are also using the 3 different models here. Pro tip, it makes sense sometimes to use smaller models specifically for a purpose because it generates higher quality outcomes then. And that's exactly what we did here underneath. But what does it mean now from the engineering perspective? Let's go into watsonx as a studio. We start with the prompt depth. Basically, what you all have experienced probably also with ChatGPT, you don't have much degrees of freedom, but usually in the platform, you would specify how your prompt looks like. Let's take one of the safe prompts that I prepared. We start with an instruction. Tell the model first what this task and this outcome should be. Read the insurance claim description and extract car, model, make, location of the incident, and so forth. So this gives the model some guidance, what is expected as an outcome. And to improve the quality, we also provide, in this case, 6 examples. Claim descriptions on the left, and also where we know and make sure these are good examples of expected outcomes on the right. Based on these few shots, we tune the model and can use it. This is basically a developer, data scientist, prompt engineer perspective. We can run it, try it out, a few examples, works well. Okay, why not deploy it? So how do we do it professionally? First of all, not just a list of prompts that we have from different projects, but organize all these assets into projects. Here we have a list of projects, members who are collaborating, and we see basically two types of assets for this simple example, data assets and prompts that are here stored and linked to this project. Data assets, these are the ones that need to be registered and linked to the project because we will use them also later for testing and validation steps. And we need to make sure that this is later recorded, so it's audit-proof, so that we have a version history of these data assets, as well as the prompt templates as well. All right, with governance and all the regulation now that takes up with the EU AI Act, for instance, in the US, similar, we have precision regulation, meaning we are not just looking at AI as technology that we want to regulate, but we want to regulate the use cases. And this is the first-class citizen here as well for watsonx Orchestrate. AI use cases. They have a risk attached to it individually. And depending on the risk, we have to account for these regulations differently. For instance, if you predict cancer, it does have a way more severe impact than if you're just recommending movies to other users, for instance. So here, we have one use case defined for the claim application, application that you have just seen. And if I go to the application, you have a status. Right now, it's still in development status. It could be in a rejected, accepted, evaluated state. So we track it across the different approval stages. We have a risk level assigned to it and can share supporting information so that we also enable collaboration between development teams, data scientist teams, but also if the companies already have a GRC board, for instance, governance, risk, compliance, responsibilities, that we need to have as a separate pair in the organization so that not only the developers will approve everything, set in production, and then later things will go wrong. One common aspect is always the life cycle. The life cycle across the stages from development, testing, validation to operation. You see it here from the left to the right. And we have linked to this AI use case basically three approaches. One is the summarization, the next step recommendation, and also the information extraction, the key information extraction that I showed you earlier. So in the lifecycle perspective, you can see all the different versions. And let's start reading from left to right, but also from the bottom with the earliest version that we created. 001, it was a prompt template, and it is recorded how the prompt template was defined. We have some documentation, the stages. We're using FLAN model from Google in this case, have some additional information, documentation about the model itself to describe it. And then we have the prompt template now. The prompt template was the instruction, and then directly filtering in the user input, the claim, the report of the accident. We had defined certain parameters because they determine what the outcome will be, so they also need to be recorded in this fact sheet here. And then we run first evaluations and tests. In the development stage, we run one test. Tosin did it yesterday on this specific data set that is also recorded and linked here, but we got 12 threshold alerts. And these alerts are shown here on these scales. These are benchmarks, industry kind of approved metrics, which evaluate the quality of Gen AI outcomes. So it's a lot about text similarity. Is the content really well reflected in the generated outcome as expected? And we test this against the validation and or testing data sets where we have good examples, gold standards, from users manually generated, where we really make sure or know about these test data that they are good examples. And here we say similarity to the expected outcome is very far off, for instance. Rouge, Ngrams, are the key items included in this generated text as well. Basically, it's not generating good enough summaries in this case. But there are also other aspects, like do we generate hate, abuse, or profanity speech? No, gladly we did not here. And also, do we process or also do we generate any PII information, personal information that we definitely don't want to see? Well, at least this was working well here, but the quality was not sufficient at all. Model health, non-functional parameters, while we are observing, is it performing well, have been recorded as well. And then we propagated this also to a validation status by another team, but it was failing again. Still, even with another data set, it was not working. Quickly, to show you then how we overcome this with a second version that we registered here as well, is we adapted the prompt, we added examples, choose another model, and basically what we generated were sufficient results. And this is all tracked, audit-proof in this platform. You can export them in documents where you have everything summarized, and you can give it to your auditors once it is needed. That's just the design development lifecycle. Next would be the operational, continuously monitoring how it is used over months and years. Is it performing well? Do we have bias trends? And the model performance is degrading. All in one place, audit-proof, and that's the purpose of the platform. I hope I gave you a good overview what we can do, what software automation can already do it. Don't take regulation as a burden. It's also just a way of professionally working in an engineering principle, like we did with software engineering. With that, I thank you.